Alright, hello and welcome to a new week. This time we're going to start some new slides and talk about these cool things called branches. So I've drawn a pretty picture because there is a metaphor with a tree involved, and just all the different ways that you could execute code. That's what branching means, and we'll get into that. So as usual, I have a lot of examples for you, and I just want to make sure you understand that you don't have to memorize anything. Memorizing is not really useful in this class. I want you to understand them, okay? These are all just examples, and they're to help prepare you for the code that you're going to write. Okay, that's the idea. So don't be scared or anything like that. I just want to say that now. So let's get into the meat of the day. So I just want to check in with you, make sure you're getting good at like these terminal-based text editors. Right? If you're stuck with Nano right now, I really encourage you to do the Vim tutor or look into this thing called Emacs, or I'll help you install Visual Studio Code. Just anything other than Nano is a good choice for you, okay? And I can definitely help you get up to speed with a different editor, one that's more capable for programming, okay? Also on the terminal, let's ignore that. If you are wondering about how to use a terminal command, you can look it up in what's called the manual. It's funny. There's a command called man, which is short for manual, and then you can be like, man ls, man pwd. What do they mean? What do they do? You can look them up in their manual pages. So man ls, and then you can scroll up and down with your arrow keys or your Vim scrolling keys, and you can press Q to stop looking at the manual. So it's like, okay, ls, that's what it stands for. Here's all the things you can do with it. It gives you some explanations of all of these. Sometimes there are examples. Man pwd, print the name of the current / working directory. What? We have so many options. And so, yeah, definitely look into that if you're wondering about anything. ls-a, what does that do? And try it out. Like, oh, okay, this is an empty folder, but now I see dots and dots. What? That's showing me some hidden things. Interesting. All right, so yeah, definitely look up all the commands in the manual that you have time to look up. It's a nice way to learn about them. Okay, let's get into branches, and it has to do with asking questions in C++ and making decisions on what to do based on those questions and their answers. So, wouldn't it be nice, maybe you've noticed this, wouldn't it be nice to do one thing or the other in our programs? Because right now, all of our programs, they're just straight lines. They're a line, a semicolon. Some code, a semicolon. More code, a semicolon, right? It all looks like this. A, B, C, do one thing, then the next thing, then the third thing. All in that order. If I were to draw it in this little flowchart-y form, the code executes like that. First A, then B, then C. That's all you get, right? Those are your three things. Right now, notice that we have no way to print to the user whether or not a number is even or odd, right? Because we can't do one thing or the other. Because that would involve code that would look like this. Ask like, is x even? Maybe then it's called x, right? Question mark. And then if it is, the answer is yes, then print even. Otherwise, if the answer is no, print odd. We have no way of doing this right now. And then come back and do the rest of the straight line code as you like to do. There's no way for us to do that right now. I guess technically we could cheat. We could be like int x, get it, and then cout x mod 2. That would technically work, because you'd print 0 if it was even and 1 if it was odd, but you're not printing the strings at that point, right? That's cheating. So this kind of operation, this kind of branching, is something that we would want to be able to do, right? So let me teach you how to do it in C++. I'm going to use the quintessential example from the movie Mean Girls. Maybe you haven't seen it, and I'm a little too old to give this example, but I'm going to give it all the same. So here is how you determine whether or not to do something in C++. You can try one thing or do the other thing, okay? It's using something called an if-else statement, okay? It lets us branch based on a Boolean expression. So we'll talk about that. A Boolean expression evaluates to either true or false. That's the yes and the no, okay? And so we're going to code up this idea from the movie if it's Wednesday, we're going to wear pink. Okay? And so we want to be able to ask this question to the user maybe, is today Wednesday? Question mark. And if the answer is yes or true, we're going to say wear pink. If the answer is no or false, we're going to say don't wear pink or something. Okay? And so here's what the code looks like. You have the word if, the keyword if, then some parentheses, and inside of those parentheses goes what's called a Boolean expression, something that gives back true or false, and we'll talk about that. And then inside of curly braces, you give all the code that you want to have happen when the answer was yes, when it was true. Okay? And then you have your other option. After that closing curly brace, you have the word else, and then some more braces that wrap around what you want to do if this original question that you're asking, this Boolean expression, was no, if it gave back false. Okay, that thing that you were asking was not true. So that's what the code looks like, and we're gonna program this. I'm gonna show it to you. Don't worry. But that is where I want to get us. All right. I need to teach you first how to write some Boolean expressions, though. So let me show you all that. Okay. So here are ways that you can relate things in C++. Here are your operators. There's more, but these are the key ones. You have double equals. That checks for equality of two things. All right, here's 2 double equals 2. That'll give back true because obviously they're the same. This, I want you to read the exclamation point as the word not. So not equal to, that's that operator. So if you put it in between some things, like some variables or numbers, it'll ask the question, hey, are these two things not equal? And the answer is, of course, yes for this one, true, because 4 is not equal to 7. Right? And then you have your normal relational operators. Is 2 less than 3? True. Is 2 greater than 3? False. Is 2 less than or equal to 2? We can't, it's hard to type this character, and so we just put the equal sign after it. 2 less than or equal to 2, true. Is 3 greater than or equal to negative 42, true. Is 3 greater than or equal to 5, false. All that stuff. It all works out, okay? And remember, this is not equal to, so 7 not equal to 7. That will give back false. Crazy, huh? And so we could use this in our code and ask questions. We could be like, if 2 is equal to 2, do something. Else, do something else. And obviously, it's this code that's going to run, not this one, because 2 is equal to 2. And so it's true. It will run this code, but not this code. You see that? That's the idea. That's what's going on there. And so here is how we're going to code up that program. So here's my little flowchart for it, and then we're going to make it. So the first thing we need to do is get some input from the user. What day is it? And then we want to test, is the input equal to Wednesday? If so, if it's true, we're going to be like, wear pink. Otherwise, if it's false, we're going to say, don't wear pink. Okay? And then after that, we're done. So that is the flowchart that we are going to translate into code. Are you ready? Drum roll, please. So, I don't know. What should I call this program? That's a good question. I don't know. I'll just call it if-else for now, because that's our first example of it. So we want to ask the user, get input, right? What day is it? Question mark, leave some room on the same line, string, day, and then we'll ask, we'll get the string, right? Cin that word, and then we'll do stuff based on that string. So we want to branch. If today is Wednesday, we want to print, yeah, wear pink. Otherwise, if it's not, print no pink. So the if statement looks like this. So if condition, Boolean expression, stuff to do if it's true, else, stuff to do if it's false. Okay? So in here goes something that gives back true or false, and we want to test for equality. We want to see, hey, is the day equal to Wednesday? Oops. And I'm using strings, so I need to include the string library. Is the day equal to Wednesday? If so, this code in here gets executed when the day is equal to Wednesday. Okay? To that string, Wednesday. And this code would get executed when it's not. Okay, so that's that. So see out wear pink, and see out don't wear pink. Okay, and so it's one thing or the other. Either this code's going to run if it's true, or this code's going to run if this condition is false. All right? And then down here, once we're outside of it, you can just do normal code that is in a straight line again. Yeah. So that's the code. Let me show you it running, and hopefully it'll make enough sense. So what day is it? And I'll type Wednesday. Has to be exact. And then it says wear pink because it ran this. Oops. Hey now. There we go. Because it ran this code, because this was true. It plopped itself right here, ran this code, skipped this code because it wasn't false, and then continued with the rest of the code. Okay? And now if I say a day that's not Wednesday, then it says don't wear pink because it checks this condition. It was false, so it jumps straight to this else case, we say. Okay? And then it runs the rest of the code. So that's how to do one thing or another in C++. Cool, huh? All right, now we're ready for even or odd. All right, so let's make a program that checks if a number is even or odd and prints out whether or not that is true. Okay, so back to a game plan, right? So we want to get input, get a number from the user, and then we want to check if it's even or odd. So we'll think about what that means, what to do there. If it's true, we want to print even. If it's false, we want to print odd. So I'll just put quotes there. What is our condition to check if something is even or odd? Maybe pause the video and think about it. But the trick is to notice, kind of like I was showing you up here, that you can do modulus by 2. And a number that goes in cleanly to 2 is even, right? With nothing left over. So you take that input, you do mod 2. It's either 0 or 1 at that point. And if it's even, if we want this to be the true case, then we want to check if it's equal to 0, right? It's either 0 or 1. If it's 0, that means the input was even, because it divided into 2 cleanly. There was no remainder. Yeah? That's how you do it. So that is the code that we're going to eventually write. So let's do it. Even odd.cpp. So, I don't know, see out, enter a number, and then we're going to get it, call it n, or I don't know, input, reuse an input, and then we will check whether or not the input was even or odd. If input mod 2 is equal to 0, that means it was even, and we can print that. Otherwise, we'll print odd. Else odd. You see that? So that's how you do it. And so we'll compile and run this. We enter number 42, even, enter number 41, odd. Because it divides it by 2, checks the remainder. If the remainder is 0, it will run the if statements code. Otherwise, it will run the else statement. All right, so that is even versus odd, and I want to teach you some terms, okay? So let me copy and paste this. Boop. And so here is my code. There are some important things I want to talk about inside of it. So the stuff that you put inside of the parentheses is called a condition. Which makes sense. You do one thing or another based on this condition, whether or not it's true or false. Conditionally, you do one thing or another. Condition. That's called the condition. And then, it's a weird term, but it's called the body. Okay, so it's like this part's the head. And then inside of these squiggly braces, those are called the bodies of the respective if statement and the else statement, or the if part and the else part, whatever you want to say there. So everything that's between these curly braces is called a body. This is the body of the if part, and this is the body of the else part. You can have multiple lines, of course. I just needed 1. So those are your 2 new terms to remember. I'll be saying them a lot. One thing I should point out right now before we move on is sometimes you only care if something's true. You don't really care if it was false. And you don't need the else statement in that case, okay? You don't have to use else if you don't need it. You can just be like, if, check the condition, do something if it's true, and then just skip the else part and just go to the rest of your code, straight line code. And that will just only do this if the condition is true still, right? If condition is true, it executes the body. Otherwise, it skips straight to the rest of your code down here, okay? So that is something that may be useful to you one day. All right, so that's that. Let's see here. Yeah, so if I wanted to only output if it's even and just say nothing at all if it was odd, I could delete this else case. So give that a try if you'd like. And now let's talk about numbers. Let's see how we're doing on the slide. So believe it or not, numbers can be true or false in C++. It's a very odd thing to have, but it is a possibility if you ever need it. C++ is really good at implicitly converting things to true or false if they're inside of a condition. And this is sometimes not what you want. So you might forget to use a relation and it will just magically make a number. C++ will magically make a number true or false for you. That might like make things look weird, okay? And so the idea is if you say something like if 42, that is actually valid in C++. And this will actually execute its body because 42 is true as far as C++ is concerned. So every number in C++ other than 0 is true. We call it truthy because it's not really true, but it is at the same time. It converts it to true. So every number other than 0 is true in C++, and then 0 is false, okay, or falsy, we say. All right, so that's very weird. So if 42 will in fact execute its body, that's true. It will run its body right here. And then if 0, if you ever do that, this is false. So it won't execute its body, but if you had an else case, it would always run the else case. Okay, so this is the part that gets executed there. Hopefully that makes enough sense. It's very weird to think about. I don't ever want you using this until we get to more advanced topics like pointers. That's the one time it really ever might make sense. But now you know. So numbers can be true or false if you really wanted them to be. And yeah, I guess technically this is always equivalent to, and you should instead be using like, is 42 not equal to 0? Because that will give you the true, that'll give you the false here, right? So maybe use this instead, always. That's my recommendation. So now I have a question for you. We've learned some things. Try this in your mind and think about what this should print out. All right, so give the video a pause, think about it, and then we'll do it together. Let's make sure we understand all this stuff. All right, so I'm going to try and copy and paste this. Dun, dun, dun. Let's see, what do I want to call this? .cpp. All right, so let's see if I can paste this. Yeah, nice. Let's see here. Dun, 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 and let's make it actual looking code. There we go. I think it's happy. And so let's run this. Boop. Weird. So x was 41, and we check, right? We're supposed to be checking if it's 42, and you'd think it would print this, but it in fact prints it was 42. Do you see the problem? So this was definitely a trick question, and I want you to notice this issue after I've explained it to you. So hey, it was 42. What's going on here is, remember how you check for equality? Boop, boop. It's 2 equal signs. That gives back true or false. this right here was a single equality. What did that do? Well, sadly, what it did was not check for equality. It assigned. It was just as if we had x equal 42 semicolon outside of anything with a semicolon at the end like that. We set x to be 42 inside of the if statement's condition. That's possible. That's horrible, but possible. Luckily, my editor, see, is nice to me. It's like, I don't think you'd want that. It's like underlining this for me. So that's why Vim is cool. But it's not doing what we wanted to here. So this is silly, and I have to teach it to you. So x was 41. But sadly, you can put whatever code you want inside of a condition, including an assignment statement. And, well, it's going to execute the assignment statement. So it's going to make it 42. So it made x 42 for us, okay? And then we have to figure out whether or not this is true or false, because it's not checking for equality still. So what does this give back? Does this give back true or false when we run this code? And believe it or not, it gives back true, because the result of an assignment statement just so happens to be the right-hand side, which is silly. So this is what C++ was doing in its mind. It did, hey, if x equals 42, so it ran x equals 42, and then it's like, okay, I need to figure out true or false now that I've set the variable. So the result of an assignment statement is the right-hand side. So it translated this into if 42 after it set the variable, which, for its purposes, was if true. And so it both set x to be 42 and ran this code because it thought that this entire statement was true. Do you see how horrible that is? So always remember double equals if you're checking for equality, okay? That's very important. And you might be wondering, why in the world would C++ even let me do this? Whose idea was it to let this happen? Like, what do I gain from this? It's nice. It actually ends up being nice in some very small circumstances to make sure that every statement in C++ has a value that it gives back. We needed that in this case. And unfortunately, it didn't go our way. But the reason you can do that is this. Int. So let me make two undefined variables, x and y. The reason that the assignment statement gives something back is so that you can run the following code, and it looks kind of cleaner than doing it in two separate lines. So if I want x and y to both be set to 42, I can do this. X equals y equals 42. Weirdly enough, that's valid C++. That's the only reason why this makes sense and why it does what it does. Don't use it in an if statement, though. The reason this works is because, of course, x equals y equals 42. It's going to actually draw the parentheses like this, and so after it sets y to be 42, it's then going to change that to be just 42 because that's what it gives back, and then it'll also set x to be 42. You see that? And so you can chain an assignment of a bunch of variables to the same value using this idea. But it came back to bite us up here, and that was unfortunate. Okay, so remember, 2 equal signs checks for equality, 1 equal sign is assignment. Never have an assignment in your condition. That is always a bad idea. Okay? So that is very unfortunate, but now you know about it. The next thing that I would like to talk about is more ifs, right? So remember that an if statement has a body, and you can put code, whatever code you want, inside of that body, including another if statement. Totally possible, okay? So here's one way to check multiple things. So if x is even, it'll run this code in that case. So we know that x is even inside of this body. Then you can have another if statement checking if x is positive, right? And so you know if you get to this inner body that it was both even, because this had to have been true, and positive. You see that? Otherwise, you knew that it was even, because you ran this code, but it wasn't positive, so it was negative or 0, right? And so you have that. It'll finish with the rest of the code if it's not even, if we don't have an else case way down here. And then if you go straight here, that means this wasn't true, so x was odd. You see all the options that you have here? So those are things that you can do. And so this is it usually helps to draw that flowchart that I was drawing before. So the first thing that it checks is evenness. Hey, is that number even? If it's true, then it runs this code, which is going to first check if x is positive, which will either be true or false. And so if you know you're in the true case, you are even and positive. Even and positive. If you're in the false case of this inner if statement, you were even still, because you got here to this body, even, but you were negative or 0. And then if you didn't get any of these, like the rest of the code is down here, that's always going to continue the code. So everybody's going there once they're done. It's the rest of the code down here. And then if you're not even at all, because there was no else case to match this if, then you're going straight to the rest of the code. Okay? Does that make more sense, maybe? That's what's going on there. And so you can have multiple ifs inside of ifs. Okay? So that's possible. That's something that you can do. I encourage you to try it out. I think the last new piece of syntax, which isn't technically new, that I want to teach you is called ElseIf. If you put else and if next to each other, it does something cool. Okay? Technically, it's just a combination of something we already know. It's a weird quirk of C++, the reason it works like this, but it's really, really useful. Okay? So a common pattern that you might want to do in your code is to try a bunch of alternatives. See if something's true. Like, do one thing. Then if it's not true, try something else. Then if that's not true, try something else. Then if that's not true, try something else. It's a bunch of alternatives with priority, right? The upper things get tried first. So that's what you want. And there are different ways to do this, one of which involves a keyword called ElseIf. So here's the example that I want to give. Let's make a program that abbreviates a day that was given. So if the user types Monday, then we're going to output, like, let's see what I want to do. If the user types Monday, print the lowercase version, print mon or something. If the user types Tuesday, print 2 or something like that. Okay, that's what I want to do. Abbreviate the days. And so the way that we know how to do it right now is with a bunch of nested if and else if. So we first check if the day is Monday. If so, then we're going to print mon, that's the shortened version. If that's false, we know it wasn't Monday, then we can try if it's Tuesday, right? See if it's Tuesday. That's our next option. We do it in that order. There's always an order. And if that's true, we're going to print 2, because that's the shortened version of it, right? If that's false, then we'll try Wednesday. See if it's equal to Wednesday. All that stuff. Then you got options, and it keeps going, right? So let me show you how to do this in the way that you currently know how to do it, which is with a bunch of nested things. And then we're going to notice that that looks really ugly, and then we'll make it cleaner. So here's one way to do it. Oh, sorry. Let's see. Else if.cpp. So enter the day of the week. So string day. I need the string library. Get it. And then now we have the day. All right, so here's how you normally would do this. Check if the day is currently Monday. If so, output mon, new line. Okay. Otherwise, wasn't Monday. Then, all right, let's try and see if it was Tuesday. If day is Tuesday. Then, if so, we'll see out 2. All right. If it wasn't Tuesday, then, okay, let's try and see if it was Wednesday. If day is equal to Wednesday. Let's just do the work week so that I don't keep typing all day long. So then it was wed. Else, right? If it wasn't any of those, notice the way that this code is running. It's like, okay, it wasn't Monday, so it's one of these. Try this else statement, which first tries Tuesday. If that wasn't Tuesday, then okay, let's try Wednesday. Otherwise, okay, let's try Thursday. You see the nesting? See how it's going to execute? It's exactly like this flowchart. Cout. And then let's just do the work week. So if it wasn't Thursday, let's assume it was Friday. All right. Do you see all of the indentation, how weird this looks? That's kind of odd looking, but it's going to work. So else if, and I really encourage you to run this code and think about why it's doing what it's doing. Enter the date of the week, Monday. So it was true, so it's going here. Prints Mon, and then it's done because it doesn't run the else statement, right? And that was just a big long piece of code that we didn't have to worry about because we executed this body. All right, let's do Wednesday. Wed. And the reason we got there is because, okay, try Monday. It wasn't Monday, so try this entire else statement, okay, which itself is an if else, so first try it's Tuesday. Okay, it wasn't Tuesday, that was false, so do this whole if statement, if else. Okay, was today Wednesday? Yes, it was. Use this body, skip the else, and now we're done with everybody. You see how that's working? That is what's going on there. And so, this is one valid way of trying a bunch of options with priorities. First do this one. If it's not true, try this one. If it's not true, try this one. But there is a cleaner looking way without all this messy indentation as the options get more numerous. Here is the trick. You can use what's called ElseIf. You can say if something is true, do the body, if that's true. And then you can say else if something else is true. That's your second option. Then you have a body. And then you can have else if as many times as you need. Else if something else is true. Try that option, if the others weren't. And then finally you can have your else at the very end. So instead of indenting, you can just say else if, okay? And that will allow you to try options. And I think it's a bit cleaner. So the below is equivalent to the above. So I'm going to take all this. I'm going to show you how to convert. This, I think, is the way that you're going to prefer to do it eventually anyway. So instead of else with an inner if, I can skip that. Oops. Else and then if. Keep the same indentation. And then it's else if. Keep the same indentation. Yeah? Isn't that nice? And so it's just a bunch of else ifs. Try that option. Keep the same indentation. Isn't that lovely? And then finally, if it wasn't Thursday, it must have been Friday. And now, all these extra parentheses are useless because they all go right next to each other. Isn't that so cool? So this is all equivalent, and I think you would prefer it to be written this way, right? And so the idea is it is first trying this option. If it's true, it does this one. And then if it's false, if it's true, it does this one, and then it skips the rest. It's like it was written like this with a big inner if statement. So it skips the rest once we found the first one that matches. So if day is Monday, prints Mon. Otherwise, we're going to try this option. Try Tuesday. See if that one worked. Try Wednesday. See if that one worked. And the first time it matches, do its body, and then we're done. We're done with the entire if-else statement. Okay, so it's just going to print Mon twice. Once I save it, of course. It's going to print Tuesday, twice. It's going to print Wednesday. It's going to print Wed twice. It'll always work. It's always equivalent. It's just trying a bunch of options and picking the first body that matches, okay? So, I hope you find that useful. That's pretty nice, I think. So, let's see, where do I want to go with this? Let's do an example for you. So, try this. I want you to write some code using a double variable, call it grade, let's say. I want you to print some things. Print C if the grade is between these, right? We're only going to have 3 grades, let's say. C, F, and A, all right? So if the the grade is greater than 90, greater than or equal to 90, print A. If it's between like 70 and strictly less than 90, then print the C, and then F if it's less than 70. So these are kind of how that would be translated. And so I want you to try this on your own. And my hint to you is that you will need to rearrange the order in which you try these options. And I want you to think about why. All right, so assuming you gave that a try, let's talk about it. So the trick is to notice that if this was the first option in my if-else statement, then it would never print A. Do you see how it's, if the grade is 90 or 95 or something, this is true, and so this is the option that will win out. That is unfortunate. So A, this test better appear before this test, because this one subsumes this one. You see that? So that's the ordering that needs to take place here. The F can appear anywhere because it's not like, it doesn't overlap with any of these other tests. Okay, but usually we put it, you just go from biggest to smallest. That's the pattern. So let's talk about it. So grade.cp. So I don't know, let's get a grade from the user. Double grade, and then we'll get it, and then we'll do some stuff. So we're going to print A first. That's the first option to try. I think that's the best one. So if grade greater than or equal to 90, or 90.0, we can print A. Else if, that's our next option, then we can try, okay, if it wasn't greater than or equal to 90, it's one of these. Then we can try C or F. And I think the pattern, just going from biggest to smallest, always works best. So if that's true, then we'll see out C, new line. Okay? And that's where we can put that. And then the final one is F. And technically, you don't even need an if, because it's just, all right, if none of these are true, then the only other option was it was strictly less than 70. See that? And that'll take some time to learn why that's true and to notice it, but I at least want to tell you it this time. Okay? So notice that you don't have to test anymore for less than 70 because it's really the only other option. It's the opposite of this. Yeah. So that rearrangement is very necessary. So keep that in mind. Let's see. Yeah, let's run it now. So like 95, A, 75, C, 55, F. Nice, huh? So it tries a bunch of options. Oops. Didn't want to close the terminal. All right, so that's that. And in the remaining time today, I would like to show you some of these things. I would like to show you a new type. Bool. The name of the type is Bool. And it's short for Boolean. Bool was somebody's last name who invented this kind of these kinds of operations. George Bool, I think, is what his name was. And so Boolean is the adjective. That's the kind of things that exist inside of the Bool type. We call them Boolean values. All right. So what is the Bool type? It is, well, it's just another cloud, right? So like the int type was 42, 0, negative 42. The Bool type is very small, very, very small cloud. And it only holds two things, true and false. Those are values. So that is the difference. All right, so the Bool type can hold Boolean values, true or false things. So I could be like, bool b equals true. And it'll make space in memory for a Boolean value that holds either true or false, and I said it's going to hold true. All right. I can make bool b equals 42 less than 43, Because I can put any Boolean valued expression there, just like something that I might put in an if statement's condition, and it will give back true or false. It will evaluate to true or false. Isn't that nice? And then, like, because it's either true or false, I can condition on it. I can say if B, because it'll just see what B is. If it's true, it'll do the body, right? Does that make sense? It is a new type. So let me show you that. We want here. Bool.cpp. So bool b equals 42 less than 43. Cout b. In C++, when you run it like this, it prints 1 for true and 0 for false when you give a Boolean to cout, but it's really holding true or false. Okay. Bool b2 equals false. That's like it's a keyword. It is actually something, right? So that could hold false, and I can print it, and it will print a 0 for false when it's printed, at least. Okay. If you wanted to print the word true or the word false, you could use an if-else statement, couldn't you? So that works. I don't know. Bool b3 equals 42 less than 43. I can condition on that. If b3, then do something. Which is, of course, true, so it will run the body. And it prints it out. Okay, so that's the bool type. It holds true or false. And so you could put any Boolean valued expression, and it will evaluate it to true or false and store it inside of that Boolean variable. And this sometimes makes things cleaner, because you can have just a variable name as an if statement's condition. And you can do all the hard work in the initialization of that variable. All right. Yeah, I think the last thing that I want to show us today is how to combine conditions, because I showed you this idea up here. Where was it? You can technically use an inner if to check if something and something else is true. So if this part's even, we're here. If this part is positive, we're also here. So if we get to this point, we know that x was even and positive. But that's kind of clunky to have two separate if statements for that. Okay? But that is technically one way to do it, right? You could be like if this, and then inside of that if statement, where you know that if you were there it was even, then you can have the check for positivity. And so if it's inside of this inner body, then you know that it's both even and positive. That is kind of too much. That's a lot of extra work. What you can do is use what's called the AND operator. And that combines Booleans, combines conditions. It's 2 ampersand characters, and it's pronounced as the word and it combines those things. So read it like that and it makes sense. So is it even and is it positive at the same time? You can just have one body, okay? And that's how you know it's even and positive, okay? So that's what you can do there. So you can be like, if 42 is less than 43 and, I don't know, 55 is greater than or equal to 27. Got here, right? 42 less than 43 and 55 greater than or equal to 27. We'll print that. Okay, so that's called the AND operator. It will combine those conditions and make sure both were true in order to execute its body. Okay? In order to give back true as the whole thing. All right? And so that brings us to what's called the truth table for the AND operator. All right? So if you say something, some Boolean expression or Boolean variable, and b2, it's only ever true when they're both true, because this has to become one answer, right? This whole thing has to become true or false. I'm saying that it's true when both are true, and only then. So the way to see that is to draw a truth table. So what are the options for what B1 is and B2 is? If you'd like an example, just imagine that B1 is checking for positivity and B2 is checking for evenness. So if B1 and B2 are both true, then them ANDed together is true. That's the one time, okay? True, true makes true. Any other case where at least one of B1 and B2 are false, then their combined condition, their B1 and B2, is obviously not true. It must be false because they're not both true. All right, so hopefully that seems logical just based on the English word and, but that's what the operator does. Okay, so let's talk a bit more about that operator. So cout true and true, and I might have to use parentheses for this. I can't remember, so I'm just gonna defensively put them there. So this is true the only time an and gives back true is when both sides are true. All right. The other examples, true and false, will always give back false. This can be false and true, and this can be false and false. Okay. So this is the only time it's going to print true, and every other time it's going to print false. And that is something you can use to combine conditions. So the last four things being output is 1, 0, 0, 0, which is exactly the truth table that we drew there. All right, so that is a way to combine conditions. There are multiple, but and is the most logical. It's like, hey, is this thing true, and is this thing also true? I want to get back one big true or false based on that result. Okay, so that is double ampersand. Very similar to double equals, right? Those are your relational operators for you. So that's where I want to end, and then we'll come back with an example next time, and I'll teach you some more ways to combine Boolean conditions. The next one is called OR. All right, so that'll be fun, and I will see you in the next lecture for that.